Hello Year 12 Chemists, welcome to TP's Chemistry Cuts. In this short clip we go through a simple calculation involving the equilibrium constant Kc.
Okay, so this is the actual question. And what you're asked is you've basically given the equation here, and you've got a value for Kc here, and it tells you that the concentration of hydrogen iodide in the reaction mixture is this. And that's all you're given. And you've got to work out what the concentration of hydrogen gas is. So, I tell my year 11s this same thing. When it comes to this type of problem, what you should do is the very first thing you do is to actually highlight what you've been given in terms of values, because you're going to need to use those. The rest of it is going to be there just to make a question up, and it's just peripheral writing, so you can forget it. So what we have here is Kc. Okay, so that's self-apparent. And the only other thing is this value here. And so that means that the concentration of Hi is equal to 0.720 mole per litre. Okay, now don't worry about units for the moment because we haven't covered moles and what that means. So don't worry about that. What we need to find is this. So the concentration of hydrogen equals question mark. So we've been given a value of Kc, we've been given a concentration, and we've got to find out another concentration. So the next thing we need is an expression relating those things together. Okay? So let's write that out. And that's the expression for Kc for this reaction. So Kc is equal to what? No. The expression, not the value, the expression. Concentration of Hi squared. It's good that lots of people are trying to answer this because it shows you that you're getting it. Yes? Now, the problem we have here is that there are 3 things on here and then a 4th thing here. We've only been given 2 and we've got to find out a 3rd. So we need to do something first. Okay, and this is what often gets people a bit confused. What can you tell me about that and that? If you read from that, there's something in there that will help us to simplify that concentration and that concentration.
Equal amounts of hydrogen and iodine gases.
So we're using equal amounts of hydrogen and iodine gases. So if I say the amount, which we've got to find out, x, this is x, because we've got to find out what x is, yeah? Is that all right? So if I say that that's x, what's this? X, because these equal quantities. They're equal concentrations. So I've got 2 x's. This is equal to 0.720. And this value is 49.5. So that's how you would start it. What values have you got? What expression are you going to put them in? Is it possible to simplify that expression before you do anything else? Have I still got everybody with me? Where have I lost you? At the beginning. So the first thing I did was work out what things I've been given. Yeah, the values. Now I need an expression that relates all those values together. Okay, and that's the equilibrium constant expression, not the value, but its expression. And I can get the expression using the equation. That's what we did in the last lesson. So I end up with this. Okay, that's using the equation together. Now, having highlighted them, I'm putting the values in. The only problem is that I've got 2 things here, not 1. However, it tells me in the question those 2 things are the same. So it doesn't matter which one I'm going to do, either will do. So if I just put x, which means I don't know what it is, I'm just going to call it x. Yeah? So I've got x and that's x. Those 2 values I know, so I can put them in. Okay? So what I'm going to do now is write that exactly as it should be. 49.5 is equal to 0.72 over x times x, which is x squared. Okay? Now,
So when it says amounts, is that the same as concentration?
yes, in this case it's the same as concentrations, yeah. Because it's in the closed and enclosed vessel. Okay? So, this is where the maths bit comes in. I have now got to work out x. So this is very, very rudimentary mathematics. The thing that I need to calculate, the x, that's the thing I don't know what it is, needs to be on the left-hand side of that equation. It always is. It's what we call the subject of an equation. Forget that for the moment, okay? So this needs to be on that side. It also can't be down. It's got to be at the top, on its own. Yeah? Always on its own. So it's got to be x equals. And all the values I know have to be on this side, so I can calculate it. So the thing we're calculating, the subject of the equation, must be that side, and all the numbers we know must be on this side. That's the way that the maths works, okay? Now, an easy way to see how this works is I'm going to change that slightly to that. Does that confuse you at all? If I put over 1, because it's the same thing, isn't it? If you divide it by 1, it's still going to be the same number. But that's now a fraction. And that's a fraction. So I've got two fractions. Yeah? And now what we do is cross multiply. So anything that we want to move from one side to the other, and we've got to move things, we've got to move things on this side that we know onto this side, and things that we don't know, this one thing we don't know, over to that side. If it's down, we move it up, and if it's up, we move it down. Yeah? You cannot move them across as such. You've got to cross multiply. That's what it's called, cross multiply. Okay? So, I need this to be on that side. Does that make sense? This is the subject of my equation. It's the thing I don't know what it is, so I have to have it on the left-hand side. The subject has to be here. So, it's down, so what do I need to do? I've got to move it up. Yeah? So, anything that's down below the line must be up. A denominator must become a numerator if you're moving it across. So, this is going to go up. Yeah? So what I'll end up with is 49.5 times x squared is equal to 0.72. The problem is, I've still got this number. Oh, I've forgotten to divide by 1. Okay? I've got this number here. I don't want that here. I need it to be on this side, because it's a known number, it's a value. So I need to move it from this side to this side. So what do I need to do? Do I move it down or just across? Down. Got to move it down. Always down. So this. So if I've moved that up there, that's over 1 now. There's nothing left. Yeah. So this needs to go down here. Yeah. So if I can just come up here, I get x squared over 1, I'm leaving the 1 there, equals 0.720 divided by, I've still got that 1 there, times 49.5. So if you cross multiply, it means you're moving it down, but you're still multiplying by it. Yeah? Always multiply. So I've now got this. If you're dividing by 1, does that make any difference to the number? No. So I can get rid of that now, turn it back to that. If I multiply by 1, does that make any difference to the number? No. So I can just put 0.720 divided by 49.5. Yeah? You still with me? So now x is equal to the square root of all of that. Can I have somebody work that out for me?
0.0145.
0.0145. 5. And the units, as you'll learn when we come to do quantitative analysis, for the moment you just have to memorise them, are moles per litre.
The square root is 0.121.
Okay? 0.121.
121.
Now I apologise for oversimplifying that for some people, but for some people that is a challenge, and it doesn't need to be if you just follow those simple rules. So anything up goes down, anything down goes up, and it's always multiplying, never addition. So what I've done again is I've basically highlighted the values that we're going to use in our calculation. Okay, so by putting them like that. If you do this in pencil on your paper, that's fine. Just be ignored. Cross them out afterwards. It will not be taken as part of your calculation or anything. Okay? So you can do this in pencil. Then write your expression. You're going to link your values that you've got together. How do they actually relate to each other using an equation in some form? So that's what I've done. I'm highlighting all the values I've got and the ones I haven't got. I can then set up an equation with the numbers in it and solve that equation by basically cross-multiplying numbers. Okay? So that's all I've done. Sorry? You should show your working, because if you do and make a mistake somewhere, then you'll still get marks for it. If you make a mistake and don't show any working and get it wrong, you'll get nothing. Okay? Because we don't know how you've got that number.